Yeah, welcome to my YouTube channel. We are going to look at using trapezoidal rule, whereby we have a number here. Use the trapezoidal rule to estimate the integral from 0 to 1 of x squared dx using 4 intervals. So now here, what are we supposed to do? Remember, for trapezoidal rule, it says that when you are integrating a number, let us say from A to B, yes, for this number is from 0 to 1. Integral from 0 to 1 of x squared dx is equals to h over 2 in brackets the first term plus the last term, then plus the 2 of f1, f2, f3, whereby here if 0 is the same as because we are moving from f1, f0 up to f4. So this one is the trapezoidal rule. So what are we supposed to do? We have to get h, which is the step size. Then, whereby h is, you get the interval, which is from 1 to 0. So we do the subtraction. We subtract b minus a, where b is the this interval, which is 1, the upper, where 0, where a is 0, which is the lower interval, over the number of subintervals which they have told us to find, which is equals to 1 minus 0 over 4, whereby 4 is the subintervals. We get this. Now, we have so far gotten h. That's right. Now, we are going to get these ones, the f's. Now, for the first one, if we say, now, the importance of this h is to help us to get the intervals from here up to from 0 to 1. We are going to be adding the first one. The first interval starts from 0. Now, we are going to add our h, whereby h is the same as 0.25. What are we going to do? We are going to add 0 plus our h. Yes? You get 0.25. That one remains. Then you get this one, 0.25, plus again our h, which is you get 0.5. Now you get 0.5 plus again our what? Our h. You get 0.75. Then you get 0.75 plus again our h is when you get 1. Remember, we are moving from 0 to 1. And then how do we get now these are like this one, you can say f. This one is the same f of x, where x is this, yes, but this one is like f of 0, f of 1, f of 2, f of 3, f of 4. You get. Then how do we get f of 0 or f of x? For this, you get a substitute this one. We substitute it here. We substitute it. For example, this you can say let f of x equals to x squared. Now, for us to get f of 0, we substitute 0 where x is from here, you get 0. That's why we got 0 here. Now, to get f of 1, we get this one. We put where 0 is here. Okay, we put where x is. You get 0.25 squared is where we have gotten this one. Now, to get this one, we get 0.5 squared is when you get this one. Now, to get this one, you get 0.75 squared. You get this one. Now, to get this one, you get 1 squared. It remains 1. Yeah. Now, after us getting these ones, our f's, we have also gotten our h, which is this one, and our h has helped us to get the intervals from 0 to 1. Now we substitute it in the formula, whereby this one's the formula. Yes. Now here, remember our h is 1 over 4. If you don't want to use fraction, you can use decimals, which is 0.25 over 2, which is this one. And you say 0 plus 1, whereby this one, remember we got for f of 0, we got 0. Now f of 1, we got 1, plus the 2, bracket 0.0625, plus, whereby this one is our f of 1, which is this one, plus 0.25, which is this one, plus 0.5625, which is f3, which is this one. Yeah. Then we do the what? You can decide first add this one, or then you multiply times this one, then plus this one, as we did here, whereby our last answer is 0.34375. That's when, if they have told us to use the trapezoidal rule to estimate the integral from 0 to 1 of x squared dx using 4 subintervals. We have used 4 subintervals, 1, 2, 3, 4, meaning, okay, we are moving up to 4 subintervals. That's why we are moving from 0 to 4, we end the 4. And these ones, our h has helped us to find these ones until we reach the upper limit. Now, if they have told us to find the to determine the percentage error. Remember, for percentage error, its formula is error over exact. Whereby, let us first find the exact. We get the exact of the other of the integral from 0 up to 1 of the original function. Now, how do we get the exact? It's just integrate direct, which is when you integrate x squared, you get x cubed over 3 from 0 to 1. That one, the limit, no problem. And then we get, after substituting the limit, it will be 1 cubed is 1 over 3 minus, it will now here will be 1 over 3 minus 0 over 3. Now this one is the same as 0, no problem. Then we get 1 over 3, which gives us that this. Now that one's for exact. Now we have to find the absolute error. Remember, for absolute error, it's the same as the error, but for it, you take the magnitude. Meaning, if you get a negative, it changes to a positive. No, there's no problem now. Whereby when you get this one's exact, which is 1 over 3 minus the approximate. Remember, for the approximate, we got it from here. whereby this one is the same as 11 over 32. This fraction, when you get this one over this, you get this very one here. You get this very one here. 3, 4, 3, 7, 5. Yeah. Then we get this, which is the same as this. Now, what is the relative error? Remember, for relative error, it's the same as the absolute error over exact. Remember, for absolute error is the same as this one which you have gotten. So what are we going to do? We get the absolute, which is 1 over 96, which is this one, divided by the exact value, which is 1 over 3. Meaning this one is now our relative error. And now the percentage error is the same as the relative error, which is this one, times 100, giving us 3.1%. Remember, the formula of finding percentage error is the same as relative error over exact times 100, whereby relative is the same as absolute error. Sorry, this one is relative error times 100, whereby the relative error is the absolute over exact. This one is okay. Okay. Thank you for listening. I request you to subscribe to my YouTube channel. We'll continue uploading this kind of math problems. Thank you.